All right, so in these examples, what we're going to look at for here is this is actually a proof. So it actually tells us and lists down what what properties are being used here. They give us the given, subtraction property, division property. We talked about the inverse of the square root is to square both sides and things like that. So this is actually listed as a formal proof, and what we have to do, just like on the test, is you have to tell where does the error lie, or is there an error in the proof. So let's look at the first one. They give us the statement, just like what we looked about with proofs before. They give us the statement that we have 3 times the square root of x minus 2 plus 5 equals 32. That's what's given to us. Okay? Then they say that on step number 2, they apply the subtraction property. Well, let's see if that makes sense to what we should do. Well, in order to get this by itself, what would be the first thing that we should do if we treat it like it's the x? Well, we would subtract 5 over, right? We would subtract 5 over, and we would get 27. So was the subtraction property right? Yeah, okay, that would be the first thing that we would want to do, is we want to subtract 5 from both sides. Then, from there, we still don't have the square root by itself. We still have a 3 being multiplied. So what would be the opposite of multiplying by 3? Dividing by 3, right? So to get rid of this 3, we'd have to divide by 3 to both sides, which would indeed be the division property. And we get 27 divided by 3 gives us 9. Okay, so far it looks okay. They subtracted the 5 to get 27, divided by the 3 to get 9, and so the first 3 steps look okay. From there, what would you have to do? Well, the square root is now isolated, right? So wouldn't we square both sides? Yeah, we would square both sides, right? And we know that our inverses would cancel, and we'd get x minus 2. And then 9 squared, 9 times 9 would actually be 81. So it looks like that's where the problem is, okay? They got a plus minus 3 instead of 81, okay? So they didn't do the opposite. They didn't square both sides. In fact, they square rooted the 9 to get to a 3 instead of squaring it. So that's where the problem was. They should have done the inverse of the square root, but instead they actually took the square root of 9. So the problem is between steps 3 and 4. Okay? The problem here is between steps 3 and 4. They should have got 81 and they got 3. So it doesn't even really matter about 5, because after that, that's no longer the issue. The mistake happened at 3 and 4. Okay? Let's look at the next proof. So on this given one, again, we want to get the square root by itself. So what would we have to do first? We'll treat it like a 2-step. We'd have to subtract 8 from both sides, right? Okay. And then we'd have 16 minus 8, which would give us 8. So that looks okay, and that's the subtraction property. So that looks okay. Then we have 2 times the square root, right? We got to get rid of that multiplication. So we'd have to divide out this 2 from both sides. The 2's would go away, and I'd get x plus 4. 8 divided by 2 would be 4, and that's the division property. So that looks okay. Then what do we do once we get the square root by itself? Well, we square both sides, right? So we're going to square both sides. Inverses go away, and I get x plus 4. 4 squared gives me 16, and that was the inverse of our square root, squaring both sides, so that looks okay. Then the last step here, when we have to subtract the 4, right? So let's see. If I get rid of this just for a second, we'd have to subtract 4, and we should actually get 12, not 20, right? So the mistake here is they applied the addition property when they should have done the subtraction property. Okay, so that's the problem here, is between steps 4 and 5. They did addition when they should have done subtraction. They did 16 plus 4 instead of 16 minus 4. Okay?